remember the pattern of when you take I to different powers, right? I to the first is I squared is -1, guys, right? I to the third would be I squared times I, but I squared is -1, so that's -I. I to the fourth would be I squared times I squared, but that's -1 times -1, which is 1. Now notice the pattern. We went from 1, 2, 3, 4, and we got these 4 answers. Okay, then we start with I to the fifth, and we go down. I, 5, 6, 7, and 8, and it's the same pattern. And then we could do 9, 10, 11, and 12. It's the same set of numbers every time. So what you notice is every time you raise I to a multiple of 4, the answer is 1. Right? It's always 1. 1, 1, 1. Right? If you raise it to a multiple of 4 plus 1, like I to the fifth, right, or I to the ninth, the answer is I. Right? If you raise it to the next power, which would be an even power but not divisible by 4, it's always -1. And if you raise it to like 1 less power than a multiple of 4, you get -I. You just got to know this. If you can figure it out for these 4 numbers, then it works for all of them. Now again, you may put it in the calculator, right? And I did it in the calculator before just to show. Try to do I to the 63rd and see what you get. Okay, did you get what I got here? Okay. So here's what that's telling you. That this is the calculator notation for 3 times 10 to the -13, which is 0.0000000000003. It's the calculator not rounding off. When you see this, whenever, because this will happen when we're finding x-intercepts in next chapter, the calculator just is not rounding this to 0 like it should. This is actually 0 minus I, which is -I, which is what we would expect for something raised to the 63rd. That's 1 more, or one before the multiple of 4, 64. Oh, I can't do that. Right? That's, if it's 1, like 3, there's the multiple of 4, the one before is -I. There's the multiple of 4, the one before is -I. There's the multiple of 4, -I. There you go. Every time the same.